Okay, solve the equation. Okay, so we're going to solve this equation here, and it's going to be for 0 less than or equal to x less than or equal to 360. Okay, so the one thing to remember is you have cos and sine. Now there's an equation called sine squared x plus cos squared x equals 1. If I was to just have nothing but cos in this equation, it would mean that I'd be able to solve the equation like a quadratic. Okay, so it's going to be sine squared x equals, and then we move this over to the other side, sine squared x equals 1 minus cos squared x. Multiply it out, we get 2 minus 2 cos squared x, we get 3 minus 3 cos x. Okay, now we're going to move it over one side and we get 2 cos squared x, and then we're going to get minus 3 cos x. 3 minus 2 is plus 1 equals 0. Now this is a quadratic equation. In the same way you could write it as 2y squared minus 3y plus 1, where y equals cos x. Okay, so what we can do next is we can solve this equation using the reference number. Reference number is going to be 2 multiplied by 1, which is 2. Two numbers that multiply to give you add together give you minus 3 is minus 2 minus 1, so it's 2y squared minus 2y minus y plus 1 equals 0. 2y into y minus 1 minus 1 into y minus 1 equals 0. 2y minus 1 bracket y minus 1 equals 0. Then we get y equals 1, or 2y minus 1 equals 0. 2y equals 1, y equals a half. Now what we have here is that because y equals cos x, we're going to have cos x equals a half, or cos x equals 1. Now cos x only equals 1 for two parts, two quadrants, okay, or two different parts. Okay, so if you have the unit circle, okay, and the unit circle is along here. So this one here is 1. We go all the way around again and we get 1 again. So if you cos inverse 1, you get 0. Cos inverse 1, you're going to get 0. Okay, so that means that x can be equal to 0 or 360 degrees for cos x equals 1. Now for cos x equals a half, we have ASTC, anti-stochastic cars, I remembered off. We're going to cos inverse a half. So cos inverse a half, you cos inverse a half, you get 60 degrees. So x equals 60 degrees. Now remember, it's also negative in the fourth quadrant, and the rule for the fourth quadrant is 360 minus your reference number, which is 360 minus or 60, which gives me 300. You can just check that out yourself. Cos 300 equals a half. There you go, cos 300 equals a half. Okay, and that's that question done. 4 answers for that there they are. Now next one, we got the three-dimensional helicopter problem. Okay, so A and B are two helicopters helicopter landing pads on level grounds. C is another point on the same level. Another point on the same level. BC is 800 meters, which is this here. AC is 900 meters, and we're told that BCA, B to C to A, that's on level ground, is 60 meters. So what I'm going to do first is I'm going to construct a triangle along the bottom here. So it's going to be this one to this one to this one. Okay, then once I have it constructed, I'm going to bring it out. So I'm just trying to bring this graph out. There we are. There it is there. Okay, now that's that's the triangle BAC. It's on flat ground. It has 900 going this way, 800 going this way, and an angle of 60 degrees. What I'm going to do is I'm going to find out what AB is for a start. Okay, because it'll give me more information. So I'm going to use the cosine rule for that. Cosine rule is a squared equals b squared plus c squared minus 2bc cos a. I have two sides and the angle in between them, which is classic cosine rule. So we're going to call this x. So it's going to be x squared equals 900 squared plus 800 squared minus 2 times 900 times 800 cos 60. Going to put that directly into the calculator as 900 squared plus 800 squared minus 2 bracket 900, so 800 squared. Oh dear. So we'll try this again. 800 squared, press the right button, minus 2 times 900 times 800 cos 60. Put that in, and you get 730,000, right? So x squared equals 730,000. Now we're going to square root this, root our answer, and we get 854.4. Okay, so just remember that x equals 854.4. Now, once I had an extra little piece of information I was looking for here, or 854.4, what I can do next is it goes find AD in search form. So I'm looking for AD here. See AD? Now there's a good bit of information on AD. So BCA 60 degrees, and what it want me to do is it wants me to find AD in search form. Then upon finding that, it then wants me to find BD. Okay. Okay, so the next thing I'm going to isolate is I'm going to isolate my right angle triangle here. It's the right angle triangle ADC. So I'm just going to draw it here. See this ADC triangle? Now ADC, like so. Now the ADC triangle, it says that C looks up at the person C observes the helicopter to have an elevation of 30 degrees. So this person at C here sees it at 30 degrees, and this is the helicopter at point D, and this is point A. We already know that AC is 900. Okay, so we know that AC is 900. So I'm just going to get rid of get this part here, bring it down. So we know that AC is 900. So what we're going to do next is we're going to use going to figure out what the height h is. Okay, we'll call it HDA. So tan 30 degrees is opposite over adjacent, which is 900 divided h divided by 900. Therefore h equals 900 tan 30. 900 tan 30 is going to equal 519.62. Now it said I wanted it in third form, okay, and for some reason when you enter it in the calculator as 900 tan 30, it isn't going to give it to you in third form for some reason. This is going to give you 519. Okay, so what we're going to do instead is we're just going to get tan 30 on its own. So here we see tan 30. Let's get tan 30 on its own. It's root 3 over 3. So tan 30 on its own is root 3 over 3. And that's a 900 on the outside. And then 900 divided by 3 is 300 root 3 equals h. See, we divided the 900 by the 3 to get 300 root 3 equals h. Okay, so that's our h value. So now I have that as 300 root 3. Now it wants me to calculate BD, BD being this length here that I will do in this triangle here, BD. Now we also found out earlier on that this 854.4 is AB. So now we have quite an easy triangle to work with here. Because the triangle we have to work with is going to be this triangle here. It's going to be ADB. And ADB has a 854.4 on the bottom, 300 root 3 at the side. So 300 root 3 at the side. And then all we have to do is find out what BD is. So that's B to D. And that's A. So I'm going to find out what this is now. So we'll drag this down. Oh, sorry, didn't group that properly. So we're going to drag this part down separately, and so, and work on that there. Okay, so that's BAD, triangle BAD. So we'll call this y. Y squared equals 854.4 squared plus 300 root 3 squared. Put that in the calculator. So 854.4 to be squared plus bracket 300 root 3 to be squared, and you get this number here. We're going to square root this number, and we get this number here, which is very close to 1,000. So we're going to say y equals 1,000 meters. Okay, and we're done with the test.